material for that one. So I will go through the material and I will cover those topics. So the first one is strings. So in strings, we know what is a string. It's a collection of characters. Then there are some functions in string. There are like strlen to check the length of the string. So for suppose we have a string. So this is a string, right? Group of characters. So in on top of the string, we can perform some operations using string strings.h header file. String.h header file. We will have some operations on top of that, like length to convert the like if we have like this, we can convert this to uppercase and this again to lowercase. So to perform this one, we will use str upper from lower to upper and upper to lowercase. So we have str lower. These are direct functions, and we have str compare to compare between two strings. This actually works in three ways. If like I have two strings s1 and s2, like s1 has 10 characters and s2 has if s2 has 11 characters, so think of 8 characters, and if it is greater than, it will return true. If it is less than, it will return false. And both if are equal, both strings are equal in length, then it will return 0. I think this one won't check the equality of string. This will check only the length. Based on the length, it will compare. And we have another function strcat and str. It is actually str copy. Correct it. It is str copy. To copy string from one variable to another variable, we should use str copy, and we have str reverse. To reverse this particular word, we can use the directive using str reverse. So those are the functions, top functions which we have in a string. Those are strlen to get the length of the string, str upper to get to change lowercase character string to uppercase character string, str lower to convert high like higher character strings to lower character. We have str compare to check the to compare two string characters, str cat to concatenate, str cat I think it is str concat, yeah, str cat to add. So now we can see some examples here for the same functions. So strlen, as I told, it is for length to get the length of the particular string. And next str upper to convert this to top case, str lower uppercase to lowercase, str compare to compare two strings. If first string is greater than second string, then the result will be true. If first string is less than the second string, the result will be false. If first string is equal to second, then the result will be 0. As I told, it doesn't check the equality. It will just check by character. A string function basically used for the purpose of comparing two strings. The string function compares two strings character by character, but not it doesn't check the equality. I think I already shared this material to share with you guys. Venkat, can you please share with them again, or I will send in the chat group chat one more time. I will share with Venkat one more time to share this material. Actually shared last week itself. By that you can follow in the options of my classes. Next we have str cat to compare two strings. One more thing in this material, it is total of 170 pages, but don't be scared of the number of pages because it is very all of them are like programs only and examples. By that it is less. You can write the same thing in examination also. It's like very easy. Like you can mention what are the string like this point by point, and then you can mention the functions that which is in a simple program for that one and the main functions in the string like this. Okay, so I will share material with you one more time. Please ask Venkat. I already shared like more than 7 days before, 6 or 7 days before itself. I shared this one. We will see now some examples on top of whatever we have seen here for str string functions. So now we have a string file. We have declared two character strings, and we are reading from them by from the input by using scanf, and we are printing it. Okay, and here I used length str length function to check the length of this string one. I'm compiling. There is no errors. First name. It is taking Imra college, so I will just add here slash n. Escape character here I will add. I will do one more time compile, one more time execution. So you can see there are four characters in string one. So this is of string one and this is a string two. So I printed side by side. The length of is 4. Now there are some other functions also, right? We have str lower and str upper. Let's compare them also. Now let's change string str1 to uppercase. And str2 to lowercase. Not this one. I shared one more like last week when I said I'm not going to take class. I will share with you one more time. Okay. So now let's do these operations str lower and str upper. Let's copy those functions str upper and str lower and str compare also will do. uppercase, lowercase. Okay. I have declared a variable two times. That's why this we got the same error. It is telling like length is already defined previously. We cannot give a variable. We cannot declare variable two times. Yeah, this one. Okay. So as I have printed percentages, it printed ASCII characters of those. We have to print strings in percentages. Save the program. See I have given JABB, which is a small character, and it converted to caps. And I have given shake as capital letters, but that converted to lowercase by using the string functions. Same way we have another functions like str compare and str. So we can give this one directly, or directly we can give here. Here compare. I'm comparing with one with str string two. Okay. So I'm giving what it is returning. What is the return type of it? It's a character. Okay. Okay, I might not have saved. Sometimes this happens with the compiler. Should print str compare. Or let's copy these functions. I'm just changing name to S1 to S2. I'm comparing S1 and with S2. S2. Okay. This might be some error, but you just refer to that material. In that whatever it is there, it will be just done like that one only. So there might be some issues here. So to compare these characters will get, and str cat is nothing but to transfer this instead of directly. So now we have Gaurav and Aurora, two characters, two strings in str1 and str2. In Java, we can use simply plus, like here if we give, we just mention str1 plus str2. This will work as a concatenate operator in Java, but in C we don't have that much, it's not that much high level language as it is a little bit low level. So if you want to match these two strings together, we have to use strcat. We have to use strcat and we have to give the variables. Uh, so it will concatenate these two and it will give a single result. Now here it will be printed as Gaurav Aurora like this. It will be printed. So next str copy, same way. If you want to move from one variable to another variable, the data we have to give str copy. In strings, we cannot directly, if it is through object, we cannot directly assign the variable data from equal to operator. We have to use str copy to copy this particular data into another variable. So str reverse, in the name itself it is there. Whenever we want to reverse that particular string, we can use that one. Okay. And next, which I missed is like precedence, operator precedence we have. So in operator precedence, earlier I used to tell like to check with BODMAS. The same BODMAS principle will work here. So in BODMAS, so this is the ఇది ఒక కొండ గుర్తులా అనుకోండి in any programming language. So based on this, the execution will start. So the this brackets in BODMAS, B for brackets, which is this one parenthesis and order exponents, and that one will be executed first, next division, next multiplication, next addition, and next subtraction. Like this there will be execution precedence will occur. Okay, so now if you check in here, so parenthesis or brackets is the will take first priority, and here the associative will happen from left to right. Like we have dot operator, structure pointer, postfix, increment and decrement. The same some other we have right to left. So increment and decrement operator, if it can be postfix and prefix, both the two are there. So like we have int I equal to 0 something. If I give I plus plus, it is called as postfix. If I call plus plus I, it is called prefix increment. So this is postfix increment, this is prefix increment. Means now if I have here j, so first I will be assigned to j and then the increment will happen. In this case, if I printed I, so like int I equal 0 is there, I plus plus j. Now here if I print j, the value of j will be in this scenario it will be uh, not assigned, right? J equal to 0, 0 only. It will be 0. First it will be assigned with the I and then I will get incremented like that. So that is one trade-off with pre-increment and post-increment. It is recommended to use always pre-increment. And now we have equal to this addition. So let's see some of the examples. If you can follow later this material, I will give the precedence this one. Here total are there. So now if you see here, we have 10, 20 plus 30. So as I said in BODMAS, multiplication will be the higher precedence. So initially these two will be calculated and then 10 plus 2 operation will be happening. So here same if you see like this. So initially 10 and 2 will be multiplied. The value will be assigned and then 600 and then we go 10 plus 600, which is 610. So the result of this particular statement in C language or in anything, it will be using the BODMAS principle. Okay. Same thing. If like multiplication and division will have Same precedence, right, in the chart. So this is a higher precedence. Okay, the number is there given. So one with brackets, you will get higher precedence, and then second, these are the like lower precedence. After that, we have multiplication, division, and modulo operations. So like this, the precedence will be reduced one by a little bit. The less the number, the lower the precedence. Means if bracket comes, the brackets will be executed first. If we get and multiplication, then and will be executed first. Address operator will be executed first because it is having higher precedence, like that. So in this case, these all three we have. If we declare in a single operation or single statement, then the associativity will work from the left to right. Okay, means so here if you see, these all belong to the same precedence. So initially 10 divided by 5 will happen. After that, we will get we'll do the modulo operation. Like that, if the same precedence number we got, it will be executed from the left to right. So like I have given the example here. So in 14, we have equal to, and we have this one addition and subtraction assignment. So if we these two in a single statement, then first plus one will execute, and after that minus one will minus assignment operator will execute. That's how precedence will work. Okay, I'll send this one also. And there was one more on the recursion. We had there were like recursions are there. Actually, there are multiple kind of recursions were there. Uh, like recursion can be divided into direct, indirect, and in indirect we have again tile, head. This is all based on the flow of recursion program. How the flow is working in the recursion, based on that, we can divide it into multiple types. So the major types we can discuss here are like linear and binary. So we have seen yesterday Fibonacci series, not yesterday. In previous classes, we have seen Fibonacci series. So using iteration and recursion. So here, if you see, we have used only one uh, function which is repeating, which is calling itself. Recursive function is nothing but a function calling itself. We call it as a recursion. Here we are calling printf. In printf, we are calling fib1. So fib1, so fib we are calling here fib_n. So here it will go into this one, and here it is calling again and again this one only to the same method. So this is what we call it as a recursion. Okay, this we call it as a linear recursion because it will work until the n is there. So like from 5 it will start 4, 3, 2, 1, like this it will start. Okay, and again it will come back. So this is linear recursion. We call it as a tail recursion if it is the last statement, because here we are returning, right? Here after returning it will come. Instead of, if we don't return anything, and if it is this particular, the end condition itself is the last statement in a recursive function, then we call it as a tail recursion. Okay, we call a recursive function a binary recursion if we call the same function multiple times. Meaning, so yeah, a recursive function is nothing but a function calling itself. Okay, let's function 1, and we have function 2. Here function 2 will be, in function 2 I am writing again function 1, and in function 1 I am writing again function 3, one more function. Okay, 3 functions are there. So now we, if we, it is like we have, we can see one more. like nth feb is there. So this one is printing all the Fibonacci series. Okay. Now we have one more recursive function call, which is finding the nth Fibonacci number. So to find the nth Fibonacci number, the same recursive program we are using, but in a different way. So we are calling like this. Here we have one function, and after this one we are calling one more function. It is nothing but n minus 1 and n minus 2. So means now like 0, 1, 1, 2, 3, 4. Fibonacci series explanation is like sum of the previous now. This is the nth Fibonacci number. To get this, we have to calculate previous one and previous two, like how we saw it earlier. So, and again, I have at third position. So, if I want to get the third Fibonacci number, so it is 5. So, if I want to get 1, 2, 3, 4, 5, which is fifth Fibonacci number. If I want to get fifth Fibonacci number, so I have to get this one n minus 1 and n minus 2 number. So 1, 2, 3, 4, 5, these are the indices, right? I have to get n minus 1 means second and n minus 2 third and do the addition. Then I will get the nth Fibonacci number. You got it? So I have a series 0, 1, 3, 5, 8. This is the Fibonacci number. This we are printing in the earlier. So let's assume it will start from 1, 2, 3, 4. This is the index to assume. If I want to get the nth Fibonacci number, like 7 the Fibonacci number, if I want to get, I have to do the calculation of addition of these two, which is nothing but n minus 1 plus n minus 2. So the same thing we are doing here. We are calculating n minus 1 and n minus 2. So here we are doing using recursive function. So like assume like 4 it came. So we'll check n minus 4 minus 1 we'll check. So we'll check 4 minus 1 and 4 minus 2, which is nothing but 3 and 2. So it will go here. So initially this function will execute. This function won't get executed because in first in memory this function will be loaded. It comes here again and again this function will be loaded. Once this is terminated, then only this function will be loaded. This is how it works in the stack memory, right? So like that it will work. The recursive functions, if we use two, simply to tell, if binary recursion is nothing but if we use two functions in a single recursive call together, if it is called like this, we call it as a binary recursion. If we add one more function 3, then it will be like multi recursive calls. Based on the flow of the program and the execution, we give names for the recursion. Like let's see what and all we have. So the linear recursion. In linear recursion, a function call exactly once to itself each time the function is invoked and grows linearly in proportion to the size of the problem. So that's what the explanation of a linear recursion. It grows. So if you see in the earlier one program, we are calling only Fibonacci only one time. So in Fibonacci recursion, we are calling only one time. So after we are here, how it is possible, because we have used global variables, and whenever a function calls itself, we are storing them and we are doing the operation and we are returning it. So here we are calling a function only one time. We are not calling two times in the same line. That's what it is growing linearly. Okay. tail recursion. A tail recursion is another form of linear recursion where the function makes a recursive call as its very last operation. There is a difference between the last operation and last statement. Okay, so last statement is nothing but this is called as a last statement in our program. But last statement is different. Last statement is different and last operation is different. So here this is the last operation. If I less than j, then it is doing the operation. Else it is keep on looping. So here in this recursive function, until I less than j happens, it doesn't. This program will this recursive function won't get executed. So this function will get executed only if I less than j. Means that is the last statement. If I less than j happened and then it is done. After that it doesn't do like that. As the name suggests, a binary recursion is a function makes two recursive calls to itself and invoked. It uses binary recursion. So as I told, like Fibonacci series. So here we are doing multiple times in a same statement. We are calling two times the same recursive function. That we call as a binary recursion. So here is some material. I will share this after the class is completed. So and the other main topic is structure. Okay. So now let's go into this one. So now we have different kind of data types. We have int, we have char, we have float, and there is one more called array. So this is homogeneous. Homogeneous means in int we can store only int values. In char we can store only character values. In float we can store only float values and int values also we can store, but we will lose this precedence. And array, in array we can store multiple values. So here if you see this store only one value, like in TA if I define, it will store. So I have different data types, right? Data types, int, char, float. So this can store only one value at a time. Okay, but these are also homogeneous. Means it can store only one kind of data. It can store only int. It can store only character. We have character array, which is nothing but string. This can store only string values like this. Okay, but there is we want one more requirement where I want to store multiple values instead of only one variable. So I want to store multiple number of data. So that time we use array. So here I can define like if I want to store 100 integer values, I can store in 100 integer values. If I want to store 100 character data, so I can define an array character like a char array I can define with 100. I can store 100 character values. But here there is a catch. I can here also, even though I can store multiple values, but I cannot store other than if I have defined it as a char, I can store only character data in this particular array. If I define it as a int, I can store only integer data. So there is a requirement now to store different kind of data. Means in a particular data type, I want to store int, I want to store character, I want to store array, any other data type which is we having. So to achieve that purpose, in C we have struct. The struct in Java, if you have learned, it will be same like class. In what is a class? Class is a blueprint. Blueprint of real world entity. Now, as I said, struct and class are similar. It is also same like how we define a real world entity. In C, we call it as a heterogeneous data type, meaning it can store multiple different kind of data types together in it. Okay. So if we come to some higher level languages, struct is nothing but a class where now if I want to store information of car, so in that car, I have like how many wheels it has, what kind of drive it has, like means front wheel drive or rear wheel drive, and what type of what is the mileage. It can be mileage refers like how many kilometer per. It can be like integer. No, it can be float. It can be like 16.5 or 7.5. Like that also I can define. Um, Name of the car, brand. These are string variables. These are int. This is also string, and they can I can given as speed. This is like int. Like this, it has multiple different data types, kind of values. Okay, that all can be stored in a car. So this if we think as a variable name, okay. If it is int, I can store only one variable. If it is array, I can store these all different kind of different number of data types I can store, but only one kind of data type I can store in array, not different kind of data type. So if I define this as a struct, I can define all these data types in this struct car. Nothing, this is nothing but a class. How we define multiple variables in class based on the behavior. That behavior we can achieve using in C using struct. Okay, let's see the definition and syntax. So example is student, or like I said car, and student has like a roll number and other information with him, name, roll number, branch. So that's all of the thing if I want to define in a single one. So struct. So I can define, I can give the struct name either at the end or at the start also. I can define any star, and there is one syntax is it should end with the semicolon. Means the syntax of struct is struct name of the struct variable names close, and this is the syntax. How to initialize? Based on this name, we have to define and initialize in our class. Sorry, in our program. Okay, so I have defined struct with with whatever the data I want to store in that struct, and I have given the name. Okay, these are the members of this particular struct. This struct will be used in the from next classes, used in linked list, doubly linked list, all the operations. In data structures, we perform all the operations using struct and array. Okay, so from tomorrow onwards, or whenever the class starts, I will be going directly into the data structures. So you just read all this information which are in this material, and it will be helpful in the examination also to write more precisely and proper way. So this is the syntax. Here we have different kind of syntaxes. So struct, name, and the data type and members. So here we have to give like this. Alternate syntax is struct name, and the elements. Both are similar only here, but it is just mentioned with a different name. So here for this I can define another different name also. So I have defined struct date with the date, month, and year. I can define an alias for this one. So instead of using date, I can use today as while initializing this one. Okay. So how to initialize now? So now we have struct available with this one. So you can refer this material after class, or like how many ways we can initialize. So now we have struct student. So I can initialize in the same line at the time of declaring. So this is declared here. I can close it here, or I can declare and initialize here itself. So if you see, if you think this as object, in Java we write as a new object, right? So new class, whichever object we have, and we pass. So now here it is Ritesh, char name, character array, and next integer value, it will be assigned here, next one. So here based on this, it will get assigned. Here we don't have methods inside this one as of now. It will be assigned like this. Based on the data type and based on the sequence, the initialization will happen for this structure. Okay. So based on the, one more time, based on the sequence and based on the data type. So it's always based on the sequence. If I give int first and then after Pritesh, it won't work. So I have to give in a sequence. Initialization will happen, it should happen if I am giving like this, it should be in sequence of the declaration. Okay. Either I can do like this in the same line, or I can give in the multi-line. Means here I can define like this. Our main structure we have defined, and I can create multiple names. Actually, if you see here, it didn't end here. So if you see here, actually the termination, whenever we give semicolon, then only this will be get terminated. Like this also we can define. These are the different ways of initialization of structure. Okay. So you read through this material and you can directly copy while copying in a program, and you can execute the programs. So let's see some example here. So now I have a struct student. Type def, as I told, we can use alias. Like if I have a structure name like computer engineering student, every time I cannot call that much big one, right? So for that, if I give type def and COE, this is instead of using this one, this name, I can call using this name. You see here, struct student S1 I have declared, and as I said, a string copy will work only with like this, using copy operator. Roll number I have defined, and CGPA. This program I will give you. So if you see here, we have name, roll number, and CGPA in an object, sorry, in a structure. So we have initialized using struct here by using dot operator, and then we are just printing this one, whatever we have details in the struct. Okay, you can verify this one. Or I can define simply like this, or I'll send this file later. Okay, instead of part of this one, I will send all these programs for you. So from here I want to stop. So we will be covering before coming to the next class, you read through the material, go through the struct and pointers and other file, and I have here shared the file also. I don't want to cover file fully deeply, so you just go through the material whatever I have shared. Here we have files also defined, command line and files, how we in a programmatical way. So any programming language handles data. So if you want to write any program, like see if you want to write some college, uh, if you want to write a software to your college, so then will be having different kind of data like college branches that we have in the college, number of students, name of the students, their background, their CGPA, everything we have to store somewhere. Okay, after storing them only we can access that particular data. So without data there is no programming language. So even though if Twitter, why Elon Musk bought Twitter with that much amount means it has huge data, it has huge human behavior in it. Okay, so without data, today's world is data world. So people will pay millions of rupees for your data to access and manage your data. So if you in Amazon, if you are ordering or looking for, if you search for some item, so you will see there is some kind of notification or recommendations that will happen, that it will try to recommend you same kind of products, that is called intelligence or something like that. It will recommend you based on your search history, based on your order history. You can see multiple recommendations in the Amazon in a side corner, and whenever it will always recommend you whatever item you have purchased previously. Okay, so that's how it is happening. It is storing that particular your search history. And if you remember in your Google Chrome, whatever product you are searching and whatever um, based on your search history, whenever you logged into Facebook or some any other social media platform, you will get that particular whichever website you have visited previously, the same websites uh, uh, what do you call ads you will get. So you will get the same search histories, whatever you did search in the Google Chrome, the same search history, whatever you have done for them, the ads will be created in your social media platform or any other YouTube or any other platform you are watching. So here, these social media platforms access your data, your search history and everything, and it will be same kind of ads it will reflect. You will be notified or you will get more often whenever you search through social media platform. Okay, so this is how the data, how we store data and how we manage the data and how the companies is selling your data. So how we manage this data, that's what we will set work on the data structures and algorithms. And there are two things here, data structure and algorithm. Data structure is nothing but the how you store the data and manage the data more effectively to get some conclusion. Means like now you have 100 students data with you. Now you want to sort that particular you want to store that particular data in such a way it will be easy to access for you. Like if you store your data in an array, like number of 100 students you have fixed like 100 students now in your classroom. Okay, so if you define that particular student data in array, you can give exactly 100 or less than 100. More than 100 students if you come, you cannot accept it. That is a limitation in the array. You can store multiple by using struct. You can store different kind of data types. Means a different kind of information you can store in a single unit variable. And by using array, you can store n number of data. But the catch here is we can store only the number you have defined. Means if you have defined 10 students, you can store only 10 number of students data only into that particular variable. If you have defined 100 students in the array, then you can store or access up to 100 student number, whatever in the array you have mentioned. Okay. So the limitation here is it cannot grow in size. And at the same time, if you remember, the size of like if you have defined int array and the size is like 100, it will store 100 into 4 bytes of data. But data means in your memory, the data that which the program will acquire is, let's see in here, So int, let's assume int A we have 10 we stored. This assume 4 bytes of byte data or 1 byte anything. So in array, if we have stored int array like int A, I have defined with 100. Okay. The size of this particular data type variable that which we are storing in our memory is 100 into 4 bytes. That's what the memory is taken here. So the limitations of array is it cannot grow in size. It cannot grow in size means if you have defined 10, you can store either less than or equal to 10 only, not more than 10. If you have defined 100, not more than 100, you can store and access. Another one is data. There will be data leakage, mean not data, huge data. If we have the more the variables that we store, more the data. Means if like I have defined like assume I have started a batch of strength 100, but only 5 people have joined. Now here in this class, assume like 120 students, but now only 5 students are there. Means in RAM, this array will be created like this, right? With starting from 4 like this. But only this 5 data is used. Remaining 100, 95 into 4 bytes of data is wasted. It's not of used. Even though it is required, but it is not of use. Means I want such a data type which can grow and decrease in size. So what is the data type that we call as linked list, and how we perform operations, how we add data into it, how we delete data into it, how we manipulate this data, how we traverse to do this data. And in array, the traversing is easy, right? For 0 will start and until n we will continue, and we access all the elements in the array. In linked list, how we access this data, access and traverse, both are same. Accessing or traversing, how we traverse, how we manipulate the data, how we here in the array, if I want to in the change some element, some data in the 0th index or 1th index, I'll just take it out and add it. Okay. There is no operations or nothing like that. How we do that? How we delete? If you want to delete here, I'll just pass null or whatever empty character into that particular array string, right? How to delete in linked list? How we add an element in the linked list? In array, we just do array index and the data, right? Like this we do. But in linked list, how we do? All these operations and all these methods we will discuss in our next class in the data structures and algorithms. Okay. There will be two things. Either I will show some videos with animations, or I will explain them based on the feasibility. Okay. So better be prepared. You go through all this material, read through it. I'm not going to cover every detail in completely, but in data structures and algorithms, we will cover it deeply. Based on the timing constraint, I'm going to cover it with videos or by direct explanation and direct notes I will tell, or I will show some videos for half an hour and I will explain about them. Okay. That's it for today. We'll discuss when our next class will be, either tomorrow or Monday. We will discuss and we will let you know. Thank you.